So my dear children, within this chapter, we'll be discussing about the second main factor that going to affect for the pressure, right? So we studied that there are two different factors that's going to affect for the pressure. So the second main factor that affects the pressure is being discussed within this chapter. So in order to investigate about the second factor which is essential for the or which is going to affect for the pressure, a simple bit of an experiment is given, right? We know that there are two different factors. The two different factors are, number one is the force which is acting, and number two is the contact area, right? Contact area of the force, right? Area which the force is going to act is the second factor. So within these practicals and within these activities, we'll be investigating how the surface area is going to act, or how the surface area is going to affect, right? How the surface area is going to affect upon creation of a force, right? Upon creation of a pressure, not force, right? So my dear children, let's head on to see our activity, and we'll see how this surface area factor affects the creation of pressure. Right, now we are studying about the factors affecting the pressure. Under that, we are going to do a small bit of an experiment once again. So this experiment is quite simple, my dear children. You'll be needing soap bars, you'll be needing two wires here, two strings, one with a thick and another one with a thin wire. One should be a thick wire and the other should be a thin wire. Okay. So a thick wire or else a string and a thin wire or else a string. Then we'll be needing sandbags, right? Sandbags. Okay, we'll be needing sandbags. Then after that, wooden sheets or planks. Right, wood plank. So these are the materials that you need. You'll be needing soap bars, thick wire and a thin wire, several sandbags and some wood plank. So this wood plank is being used to keep the soap bar, so therefore it's wise to get the surface area of the wood plank so as to be equal with the surface area of the soap bar. Okay, right. So the method, let's see how to conduct the activity. So like in the previous activity where we used to hang sandbags on the bar of soap, right? In the same way, you have to place the wooden plank. Then on the wooden plank, you have to keep the bar of soap. Then by using a thin wire and a thick wire separately at two instances, right, you have to hang sandbags to intersect or to bisect, right, intersect or to bisect soap bars. So then after you have to calculate the time taken. Okay, then after you have to calculate the time taken. You can use a stopwatch for that thing, right? You have to calculate the time taken to intersect or to bisect, right? To intersect or to bisect. How much of a time taken to bisect or intersect the, the soap bar? Okay. So, it's really simple to conduct this activity, my dear children, right? So, let's head on to see what is our method. So, once again, place the piece of plank between two tabletops and keep the cake of soap on the plank as shown in the figure. As shown in the figure, you have to keep the cake of soap, right, as in the figure. Send the thick wire round the cake of soap and hang the sandbag of 20 Newton weight. 20 Newton weight means around 2 sandbags, right? Yes. Observe what happens. So, you know that this, when this thing is going to, when I'm going to hang the sandbag, you know that definitely the cake of soap would get cut by the wire. However, according to the thickness, right? However, according to the thickness, it may cut or not, right? We don't know. We have to conduct and see the activity, what's going to happen. So, what we have to do in the first instance, send the thick wire around the cake of soap, hang the sandbag and observe what happens. Okay. Then after, remove the thick wire and repeat the above step using a thin wire. Observe what happens again. What can be concluded according to the observations? Alright. So, what you have to do, take the thick wire, keep it around the cake of soap, hang 20 Newton weight and observe how much of a time is taken to intersect or cut the soap bar. Then remove that soap bar entirely. Take the second soap bar, place it on the same setup, wrap the thin wire, hang the same weight 20 Newton, 2 sandbags, then find out how much of a time taken to intersect or to bisect the soap bar. Now you have to compare the results, the time taken. Then after, you have to come into a conclusion. This is how to do the activity, my dear children, right? So, it's really simple, not that much of a big activity, a simple bit of an activity. Let's head on to the class, let's head on to the laboratory and we'll conduct the activity and we'll compare and see what are our results. So, my dear children, within this activity, we'll be observing, right, what is the other factor which is important in creating a pressure. So, in order to observe that other factor, I have two different strings with me. Here you can observe this is somewhat like, if you compare it with the other string over here, it has a greater thickness, right? It has a greater thickness. See, if you compare these two have two different thicknesses. This one is somewhat thicker, this one is somewhat thinner. I have a soap bar with me like in the previous activity, a hook and 2 bags of sand and a stopwatch to calculate the time. So, first of all, I am going to keep the bar of soap in here like this kind of a position. Then I am going to insert, right, insert the thicker string like this. Then let's insert the hook. To the sandbag. Here we go. Right. Then gently I'm going to insert this thing to the wire, to the string, and as soon as I'm going to release the hand, I'm going to turn on the stopwatch. Here we go then. So as you can see here, now the soap bar is getting cut down by the string, but very slowly. So we have to give somewhat time. So check the time, my dear children. It's around now 3 minutes. Here you can observe now the bar of soap like separated up to 3/4 of the total size, right? Up to like 3/4. It's been separated up to 3/4. So we have to give it somewhat more time to separate, right? So we'll wait for somewhat longer time. Right, my dear children, now as you can see here, now it's almost finished, right? It's almost finished right now. So now I'm going to stop my watch. So it's almost finished. Yes, so I'm going to stop it right now. Actually, it's not 100% completed, dissected, right? But however, as you can see here, it's like 90% it got separated. Okay, not 100%, but like 90% it got separated. Okay, so I'll gently remove this thing. So here you can observe like up to 90% it got separated within like how much is the time period? So it took around let's say 5 minutes. See, so it's nearly my dear children, you can see here it's nearly 5 minutes, right? Nearly 5 minutes. So we'll round it off to 5 minutes. So nearly 5 minutes and 12 seconds, we'll round it off to 5 minutes. Okay, as this thing haven't got separated totally, right? You can see here it doesn't got separated. See, it haven't got separated at all. So there's somewhat time left. However, we'll round it off to 5 minutes because it is going to take somewhat longer time to dissect the piece, this soap bar into 2 equal pieces. So let's take it as 5 minutes. Now I'm going to go for the second setup. I'll keep it in here. I'm going to take this to the 0, right? Then I'm going to go for the second setup where I'm going to use the same type of bar of soap equal in dimensions, but for the second setup I'll be using the thinner string, right? Now I'm going to use the second setup, right? I'm going to use the second bar of soap right now. So we'll use the second one, right? As you can see here, these two are identical. There's no any difference in it. Okay, so let's keep it in here. Now stopwatch is at 0. Let's hang this thing. As soon as I'm going to release, I'm going to start the stopwatch. So once again you can observe gradually here the string is gradually now getting inserted into the bar of soap. So we have to wait somewhat. Right, so my dear children, once again you can see here it's not going to separate it into two equal parts, but however now it's been separated up like up to 3/4 of the total size. So I'm going to stop the watch right now. Right, so we'll gently remove this thing. Once again you can see here it got separated more than the 3/4. It got separated right now. Okay, almost it got dissected into two equal parts. Unlike the previous case, you can see here, right? Right, see? So the time taken, now let's go for the time taken. So time taken is around 2.5 minutes. So we'll round it off to 3 minutes. Okay. So we'll round it off to 3 minutes. So in the earlier case, it was around 5 minutes, greater than 5, right? We round it off to 3 minutes, 5 minutes now. But in this case, it's greater than 2.5. However, we round it off to 3 minutes. Here you can see a 1 minute difference. A clear 1 minute difference can be observed. The bar of soap got cut very quickly, like 1 minute earlier, when we are using this thin, right? When we are using this thinner, string, right? Bar of soap got separated, or it got cut very quickly when I'm using this, right? When I'm using this thinner string. The bar of soap, right, to intersect the bar of soap, it took around 5 minutes when I'm using this thicker string. So my dear children, there is a clear difference between the time taken. Now let's head on to the classroom once again and we'll write down our observations and conclusions from this activity. Right, my dear children, so we conducted the activity and you could observe that the thick wire took around 5 minutes to cut the soap bar. However, the thin wire took around 3 minutes to cut the soap bar, right? Thick wire took around 5 minutes. However, the thin wire took around 3 minutes to cut the soap bar. So we can write our observation. Thick wire took 5 minutes. So my dear children, thick wire took 5 minutes. Thin wire took 3 minutes. This is our observation. So what is the conclusion from this activity? The conclusion is, now you can see it very clearly, thick. When the thickness means greater the surface area, right? Greater the thickness, greater the surface area. So if the surface area is greater, or if the surface area is high, you can see that more time is taken to bisect or to intersect, right? Bisect or to intersect the soap bar. So I'll mention here, thick wire took 5 minutes, thin wire took 3 minutes to cut the soap bars separately. Right? So thin wire took 5 minutes, thick wire took 5 minutes, thin wire took 3 minutes to cut the soap bars separately. So here you can see that very clearly. Thick means greater surface area. So in greater surface area, my dear children, you can see that 5 minutes have been taken by, right? 5 minutes have been taken by the wire. Why it is going to take around 5 minutes? It's because that when the surface area is high, the pressure exerted on the soap bar is very less. So when lesser the pressure which is going to act on the soap bar, right? When lesser the pressure, it is clear to us that the tension created on the soap bar is going to reduce. So thereby more time is going to more time will taken by the thick wire to bisect the soap bar, right? However, when you take the thin when you take the thin wire or the thin string, it's going to take only 3 minutes, means very lesser time. So less time means it's exerting more pressure, it's exerting more tension. So thin means lesser the surface area. So when the surface area is less, the pressure created within the surface is going to be increased. So we can conclude finally, when the surface area is less, greater pressure is observed. When the surface area is high, less pressure is observed, right? So we can write when surface area is high, less pressure is observed. Less pressure is observed, right? When surface area is high, less pressure is observed. Then number 2, when surface area is less, high pressure is observed. Right? So my dear children, these are our 2 conclusions from the observations above. Thick wire took 5 minutes, thin wire took 3 minutes to cut the soap bars separately. But however, our conclusion from this thing is, when surface area is high, less pressure is observed. When surface area is less, high pressure is observed. This is our final conclusion from the activity, right? That's why these two are taking these much of times. Thin wire 3 minutes, thick wire 5 minutes. So you can see that when the thickness is going to increase, the surface area is high. If it is going to have high surface area, more time is taken. Why it is going to take more time? Because the pressure exerted on the soap bar is very less. If the wire is thin, less time is taken. If the wire is thin, less time is taken. Okay. So if less time is taken, high pressure is acting on the surface. So therefore, my dear children, we can finally conclude that when surface area is high, less pressure is observed, and when surface area is less, high pressure is observed. So this is our final conclusion from the activity, right? Now, my dear children, we are going to conduct another different activity, right? Somewhat different kind of an activity, like in the previous case where we conducted this kind of an activity by using several weights. Okay. In the same way, here also we are going to conduct different kind of an activity. But in this case, okay, we are going to keep the same weight, we are going to keep the same force, but here we are changing the surface area and to check the thickness of the sponge. So like in the previous activity, like we did this kind of an activity under the force, right? And when we are investigating about the force, we did this kind of an activity, right? So in the same way, you will be needing several wood planks with several surface areas. Here this time you will be needing 3 separate sponge layers. 3 separate sponge layers. Okay. What I am going to do is I am going to take the largest sponge. Okay. I am going to take the largest sponge. Then I am going to cut that one into several pieces, right? I am going to conduct the first step or the first experiment, first step. Then I am going to cut that thing when I am doing the second one. Okay. Then when I am going to do the third step, or when I am going to do the third particular activity, I am going to cut it again into relevant size. Okay. So this is our this is the one which I am going to do when I am doing the activity. So it's really simple. You can take the same sponge and you can cut after doing one step at a time. Okay. So 3 different sponge layers, iron nails, scale, hammer to fix these things, and a spring balance to measure the mass of the wooden plank. Already we measured that thing and we took the largest wood plank as 4.5 Newton. However, we are going to measure once again and to note it down. Right. So we'll write down the dimensions of these things then. 15 by 10 by 1 cm. This one 20 by 10 by 15 by 10 by 5 cm, right? Then the sponges should be 15 by 10 by 5. This one 15 by, so here we have to use several area. So here 15 by 5 by 5. Okay. Then after that 10 by 5 by 15. 10 by 5 by 5 centimeters. Okay. So then after that iron nails, then a scale or else a ruler, hammer, then a spring balance. So you'll be needing 3 wooden planks, 15, 10, 1, 20, 15, 1, 15, 10, 5. Okay. Then after that, you'll be needing 3 sponge layers separately, 15, 10 by 5, 15 by 5 by 5, 15, 10 by 5 by 5. Okay. Then some iron nails, a scale or else a ruler, a hammer and a spring balance. So these are the materials that you need when doing this activity. Then the steps. Weigh the wooden block using the spring balance. Place the scale of 15 centimeters on the L-shaped frame made. Now place the sponge B on the plank. Note down the reading of the scale relevant to the upper horizontal edge of the sponge. So, like in the previous activity where we did this thing under the factors affecting the pressure. Now, especially in the earlier case, we discussed about how force is going to act or how force is going to affect the pressure. So, like in the same activity, you have to fix these two together according to the figure. Then you have to place the first sponge, okay, sponge B on the plank, and you have to note down the reading of the scale relevant to the upper horizontal edge like this. Then place the 15 by 10 centimeter surface of the wooden block on the sponge as shown in figure A. Note down the new reading of the scale relevant to the upper horizontal level of the sponge. Now remove the sponge B and place the sponge C on the plank as shown in the figure B. Place the 15 by 5 cm surface horizontally. Note down the reading of the scale relevant to the upper horizontal edge of the sponge. Right. So this is the way of doing the experiment, my dear children, right? So first of all, you have to keep this surface to come in contact with the surface 5, 15, right? 5, 15, 10 according to the diagram. Then you have to change the surface and you have to keep 5, 10, 15 according to the diagram given, right? So remember, here we are changing the contact surface, but we are keeping the same wooden block over the sponge. Okay. The contact surface of the sponge is going to change. However, the wooden block remains the same. Okay. Right. Then what you have to do? Then what you have to place the 15 by 5 by surface on the wooden block on the sponge. Then note down the reading of the scale relevant to the upper horizontal edge of the sponge. Now remove the sponge C and place the sponge D on the plank. Place the 10 by 5 surface horizontally. Note down the reading relevant to the upper horizontal edge. Then place the 10 by 5 surface of the wooden block on the 10 by 5 surface of the sponge. Now take the reading of the upper edge of the sponge and tabulate your readings. So this is the way of conducting our activity, my dear children. You have to use the same wooden block. That's the case in here, right? You have to use the same wooden block. Only thing you are changing is the shape or the, the surface which is going to come in contact with the sponge layer. Okay. So when I am going to conduct the activity, you can find out that this activity is not that much hard. It's quite simple, right? What you have to do, you have to change the surfaces one by one each and keep the wooden surface to come in contact with the particular surface of the sponge. Then after that you have to conduct, after that you have to measure the, right, you have to measure the vertical level, right, the thickness level of the sponge layer. So this is how to conduct our activity, my dear children. Then after doing all of these things, what do you have to do? I'll show the table for you guys. You have to fill out this table, right? First you have to keep the sponge layer B. Then you have to measure the height of the sponge. Then after placing this 15 by 10 one, sponge layer B means 15 by 10 surface, okay, 15 by 10 surface, find out how much is the height. Then in the next step, you have to keep the sponge C, right? Then you have to calculate, or you have to get the upper topmost reading. Then you have to place the wooden block 15 by 5. Okay, you have to keep the 15 by 5 surface to come in contact with the sponge. Then you have to take the reading, or then you have to take the topmost reading, topmost thickness level of the sponge. Then finally you have to keep the sponge layer D, right? Then you have to keep the 10 by 5 contact surface on the sponge layer. Like in the previous way, you have to measure the thickness levels earlier and after. Okay. So this is the way of doing our experiment, my dear children. So when I am going to conduct this activity, I am going to use the same wooden plank and the same sponge layer. What I am going to do is, I am going to take the sponge that has like 15 by 10, then I am going to cut it into 15 5 and into 10 5. Very simple. Okay. Then I am going to turn the same wooden block and keep it at several instances, at these two different instances, and to measure the thickness. Okay. Right then. So my dear children, this is the experiment and this is the way of doing our experiment. Now let's head on to the laboratory and we'll conduct our experiment and let's see what are our readings. So my dear children, here now we are going to do the second activity related to the surface area thing. So within this activity, I am going to use the same piece of sponge, but when I am going to interchange the sides of the wooden block in here, I am going to cut off these parts and place it on the scale like this. Okay, then we are going to take the readings. So I am going to use the same piece of sponge. Okay, right. So first of all, I am going to keep it lengthwise like this. So I have the wooden block with me. You can see it in here, right? It's perfectly getting fit on the sponge like this, right? So now I'm going to do, what I'm going to do is right now, first of all, we are going to measure the thickness by keeping the system stationary like this. Okay, now let's measure it. Let's get a reading from here. So it's between 5.7 and 5.8. So we'll assume that this thing is 5.8. 5.8, right? 5.8 is the initial reading, right? Initial reading 5.8. Now I am going to place the wooden block, right? So I have placed the wooden block in here, right? So let's take a reading over here from this level. So it's now 5.7, my dear children. It's 5.7. Earlier it was 5.8. Now it's 5.7. Earlier 5.8. Now it's 5.7. Now in the second case, I'm going to use the, right? In second case, I'm going to use the second surface, this surface, right? This surface. So for that surface, I'm going to change the, right, sponge for that surface. So now let's go for the second step. I'm going to use a different kind of a sponge, right? Actually, different kind of a sponge means I'm going to separate this thing into that kind of a length. Then I'm going to place it over here and I'm going to measure the normal length. And when after placing the wooden block, how much is the length? So let's go for the second step then. So my dear children, the second stage now. So in here you can observe I have separated a piece of sponge, right? Now you can see very clearly the surface area has reduced now. Let's measure the thickness. So I told you that these readings are very sensitive, so we have to take it into a nearest millimeter. 5.9 is our neutral reading. So the neutral reading is 5.9 in here. 5.9. Neutral reading 5.9, my dear children, right? 5.9 is our neutral reading. Now I'm going to place the surface of this wooden block like this. So as you can see here, this surface is going to exactly match. So my dear children, I have placed the wooden block right now. Let's take the reading. So the reading is now, observe the reading over here. So the reading is now at 5.7. You can clearly observe 2 millimeter of a difference. Earlier it was 5.9. Now it's 5.7. So with the reduction of the surface area, you can observe reduction in the thickness of the sponge, right? So the difference is right now 2 millimeters. Okay, difference is now 2 millimeters, right? Then the third step, I'm going to place the wooden block like this and I'm going to separate a piece of sponge in order to match with the surface area when I'm going to place it like this. So I'm going to take a piece like this and keep it over here to get the necessary readings. We go for the third step then and we'll see how much is our reading. So my dear children, the third step. Now I'm going to use the lowest surface area, okay, sponge layer that has the lowest surface area. So I'm going to keep the same wooden block, right, this one, but to have the contact surface on this sponge to have the lowest surface area. So we'll place it like this. Before that we have to take a reading, right? So after placing it we have to get the reading. Okay, so first of all we'll take the neutral sponge thickness. How much is it? So it's at 5.9 now. It's at 5.9 right now. Okay, at the neutral sponge layer thickness, the neutral sponge layer thickness is at 5.9 right now. Now I'm going to place this thing over the sponge like this. Right, then I'm going to measure the thickness of the sponge. Right, so I have placed the wooden block So you can clearly observe now the radian has dropped dramatically. In the earlier case, it dropped like 1 or 2 millimeters, but however now it's more than 5 millimeters. Actually, now if you take the reading, now the reading is at 5.2. Now the reading is at 5.2, my dear children. Reading is at 5.2. You can clearly observe it from here. The reading is at 5.2. So it's now reduced by the thickness now reduced by 0.7 millimeters, almost 1 centimeter, right? When I was placing the sponge layer just in the same way, in a neutral station, in the neutral way, the thickness was 5.9. When I am going to place this, place the same object, but to have the lower surface area, the thickness has got reduced by 0.7 millimeters. Now the reading is at 5.2. Earlier it was at 5.9. Right. So these are our observations, my dear children. So let's head on to the classroom once again and we'll write down our observations and the conclusions from the activity. Right, my dear children. So we conducted the activity and you could get the relevant observations and even we have noted it down. So first of all, what I'm going to do is I'm going to fill out the table. Okay, so let's fill out the table. Force exerted on the surface. Force exerted on the surface was quite simple. 4.5 Newton each. Then the height of the sponge, right? Height of the sponge. Height of the sponge at the first instance 5.8, here 5.9, here also 5.9. Then I am going to show the reduction. Here 5.7, I'll use a different color pen. Then in here also 5.7, but however here it got reduced up to 5.1. Now the second one, the contact surface area. So to find the contact surface area, you need to multiply length with the breadth. So you can find the length and breadth in here. 15 by 10, 150 square centimeters. Then in here 15 by 5, 75. Then in here 15 by 10, 50. Now let's go for the reduction. So in here 0.1 centimeters. 0.1 centimeters means it's just 1 millimeter, right? 1 millimeter of a thickness has got reduced. In the second step, 5.9 to 5.7. 5.9 to 5.7. So the difference is 0.2 centimeters, which is 2 millimeters. In the third step, 5.9 to 5.1. 5.9 to 5.1. Difference is 0.8 centimeters, which is 18 millimeters. Right. So by looking at the table, you can clearly observe once again. What is that? My dear children, we kept the force in the same way. We kept the force a constant. How can you say that? Because we took the same wooden plank. We measured it and we took the answer as 450 grams, which is equal to 4.5 of Newton. However, we changed the contact surface, right? We kept the contact surface to contact different surface areas with the different surface areas of the sponge. First of all, we kept to contact with 150 square centimeters. In the second step, we kept to contact 75 square centimeters of an area. In the third step, we kept 50 square centimeters of an area. So, according to that, we could get these results. Thickness reduced by 1 millimeter when I am going to place it on the surface to contact 150 square centimeters. But when I am going to keep it to contact 75 square centimeter area, thickness got reduced by 2 millimeters, right? By 2 millimeters, right? Here earlier it was 1 millimeter, but in here the second instance by 2 millimeters it got reduced. In the third instance, when I am going to keep it to come in contact with 50, thickness got reduced by 0.8 centimeters, which is equal to 8 millimeters. So, it's a dramatical change, a huge change. So, as you can see here, it's very clear to us, right? It's very clear to us that upon reduction of area, the thickness has, or the difference in thickness, right? Reduction in thickness also got increased from 0.1 to 0.2 to 0.8, or from 1 millimeter to 2 millimeter to 8 millimeters, right? When there is high surface area, the reduction in height of the sponge is very less. If the surface area high, reduction is very less. What is the reason? Because less pressure is getting exerted. Less pressure is getting exerted when the surface area is high. So, when less pressure is being exerted, right, the tension given out is also less. Therefore, the reduction in thickness is a very simple value like 1 millimeter. But when the surface area is getting reduced gradually from 150 to 75, we can see that the thickness is getting reduced by 2 millimeters. It's because now the tension acting on the surface is somewhat greater than the previous instance, as the surface area has got reduced. So, upon the reduction of surface area, right, upon the reduction of surface area, you could clearly observe that, right, you could clearly observe that, my dear children, the pressure or the tension given upon the surface is going to increase. That's why the thickness is reducing, right? That's why the thickness is getting reducing. Now, in the third instance, we are reducing the surface area even more up to 550 square centimeters. Now, here the reduction in thickness is even more. Here from 5.9 to it reduced to 5.1, right? From 5.9 to it got reduced to 5.1. Means the difference is 0.8 centimeters or else 18 millimeters. Now, my dear children, by looking at these values, we can clearly say, right? By looking at these values, we can clearly say that these values or these observations, right, according to these observations, upon the reduction of surface area, the thickness also going to not decrease but increase. Why the thickness is getting increase, or why the reduction in thickness increase, right? Reduction in thickness, it's going to increase. In the earlier case, the reduction was just 1 millimeter. Second instance, the reduction is 2 millimeters. In the third step, the reduction is 8 millimeters. What is the factor did we change? What is the factor that we changed? The factor that we changed is the surface area which is come in contact with the sponge from 150 to 75 to 50. So it's clear to us that when decrease in the surface area, the reduction in thickness increases, right? Reduction in thickness increases. When reduction or during the reduction or during the decreasement of surface area, the reduction in thickness increases from 0.1 to 0.2 to 0.8 because, my dear children, greater force is exerted on unit area of a sponge. Means that greater pressure is exerted on the sponge. That's why it is getting pressed even down. So upon the reduction of surface area, we can finally say that the pressure which is going to exert on that surface, on that particular surface, is going to increase dramatically. Right. Upon the reduction of surface area, we can say that, the pressure is going to increase. That's why the reduction in thickness also going to increase. So this is the final conclusion from the activity, my dear children. So it's quite obvious to us that surface area and the pressure which is getting created has an opposite relationship. It has an opposite relationship. When the surface area is high, pressure acting is low. When the surface area is low, pressure acting is high. These two quantities are going to show an opposite relationship, my dear children. Right then. So the conclusion. First and foremost, we can write like this. Number 1. Surface area which the force is acting. Surface area which the force is acting affects the pressure, right? Surface area which the force is acting affects the pressure. Under that we can write how it is going to affect. When surface area is high, pressure is low. Pressure given is low. Then in the next step, when surface area is low, pressure given is high. Right? So these are the ways which the surface area is going to affect with the pressure concept, my dear children. So once again, surface area which the force is acting affects the pressure. The surface area which the force is going to act is going to affect directly in the creation of pressure. Okay, how it is going to act? This is the way. When surface area is high, pressure given is low. When the surface area is high, pressure given is going to be very low, right? In the second instance, when surface area is low, pressure given is high. So these two are opposite related to each other. When one thing is going to increase, the other decreases. When that thing is going to increase, the other also going to decrease. When one is increasing, other decreases. When this one is going to decrease, the other increases. That's how the surface area and the pressure is going to work, right? That's why, my dear children, I told you that at the beginning of our lesson, at the earlier times, in our ancient times, the shop owners can easily cut a bar of soap by using a piece of thread or else a string. But it should be a very thin one. Why is that? To exert more pressure, as it has a lesser surface area, right? So by doing these two activities, we can come into conclusion that surface area and the pressure which is getting created has an opposite relationship. They have an opposite relationship, my dear children. So let's move on to see what are the other contents in our lesson. So once again, you are given with the explanation. During this activity, same wooden block is kept on all sponges. Yes, we kept the same wooden block. That's why I told you that we never changed the mass. So the weight of the object is also never going to change, right? Therefore, the force exerted on all different sponges is the same. So if the mass is not changing, then the weight is also the same, right? If the weight is same, then the force acting on all the sponges are equal to each other. That's obvious, right? But the contact area of the wooden block on each piece of the sponge is changed. Yes. By changing each of the sponge, we changed the contact surface, right? So the contact surface area has got changed in each of the instances, even though the force remained the same. Then, when the contact area is large, the contraction of the sponge is less. And when that area is less, the contraction of the sponge is higher. Therefore, it is clear that the pressure is less when the contact area is high and vice versa. So, my dear children, we can see that finally, like I wrote in the earlier case, it is clear to us that pressure is less when the contact area is high and vice versa means the opposite thing. What is that? The pressure is high when the contact area is less. When the contact area is less, pressure is high. So these are the two main conclusions that we can take from the activity above. So my dear children, we discussed two different factors that affects the pressure. One thing is the perpendicular force, or just in simple, I told you that in our O-level syllabus, always the force is perpendicular, right? So therefore, we can just mention as the force which is acting on the certain surface. So force is the first factor which is acting on the surface that affects the pressure. When increase in the force, pressure increases. When decrease in the force, pressure decreases. So force is showing a direct relationship with the pressure. However, the second factor, the surface area, is showing an inverse relationship, opposite relationship. When increasing surface area, pressure decreases. When decreasing surface area, pressure increases. So these are the two main factors, my dear children, that we discussed under the factors affecting the force, right? Under the factors affecting not the force but the pressure, right? Under the factors affecting the pressure. So actually the pressure is created when forces are acting on a unit area. So force and area both should be come into consideration when you are taking the pressure, right then. So accordingly, following facts are revealed by above activity. So once again, my dear children, what are the facts that revealed by these two experiments? We did two experiments. So what are the two facts that revealed? Let me remind you once again. Surface area affects the pressure. Surface area affects the pressure. So we'll write it down first. Surface area which force is acting affects the pressure. It affects the pressure, right? Surface area which force is acting affects the pressure, right? It affects the pressure. How it is going to affect the pressure? In an opposite relationship, through an opposite relationship. How can you define the opposite relationship? Very simple, my dear children. How come? When the surface area is high, right? When the surface area is high, when the surface area is high, right? When the surface area is high, pressure acting is low. When one thing is going to increase, the other decreases, right? When the surface area is high, pressure acting is low, right? Pressure acting is low. The opposite of this thing, when the surface area is low, right? When the surface area is low, pressure acting is high. Pressure acting is high, right? So the other factor, when surface area is low, when one thing is going to reduce, or when one thing is low, the other is high. The other factor, which is the pressure, is going to increase, or it's going to be high. So this is how the opposite relationship works. Surface area high, pressure low. Surface area low, pressure high. So this is the second factor that affects the pressure, my dear children. Right then. So according to above activities, now we conducted four different activities, my dear children. So according to these four different activities, we could finally reveal that there are two different factors that affects the pressure, right? There are two different factors that affects the pressure of a certain surface. First factor, force acting on the surface. Actually, this force should be perpendicular force. I'll mention perpendicular, but however, within our O-level syllabus, you will be receiving only perpendicular forces only to find out the pressure, right? So don't worry about the perpendicular thing that much, because in our O-level syllabus, you'll be given with questions under perpendicular forces only. Okay, right. So the first factor is force acting on the surface. We can write like this, right? I'll use a different color pen. When force is high, pressure is also high. Right? Then in the second step, when force is low, right? When force is low, pressure is also low. Right? I have explained just in my simple terms, right? When pressure is high, force is high. When pressure is low, force is also low. In simple terms, so that you can remember it quite well. This is the relationship. Then the second factor. Second factor is, my dear children, surface area. Surface area which, right, surface area which force is acting. You can mention this thing as capital A, as it is reflecting about area. This thing as capital F, as it is mentioning about the force. So surface area which force is acting, this is the second factor. Surface area which force is acting. Right, now we'll write down the way. Right, we'll write down the way. You know that surface area and the pressure has an opposite relationship. So we can write when surface area is high, when surface area is high, if this thing is high, then the other is low. Pressure is low. Pressure is low. Then in the next step, when surface area is low, pressure, right? Pressure, when surface area is low, pressure is high, right? When this thing is low, the other is going to increase, or it's going to be very high. So my dear children, this is how the surface area which the force is acting and the force acting on the surface, right? Forces or the forces which is acting on the surface is going to work with the concept called pressure. So surface area, in simple, surface area and the force acting are the two factors that's going to affect for the concept called pressure. Force is showing a direct relationship while the surface area is showing an inverse relationship, my dear children. Right then. So this is how pressure and the factors affecting the pressure works. So my dear children, this is how the factors affecting the pressure is going to work. Okay, I hope that you got a sound knowledge about the two factors that affects the pressure. Okay, so this is how the pressure is going to differ with these two factors. So my dear children, it's important to remember that always the force is showing a direct relationship with the pressure while the area is showing an inverse relationship with the pressure. Okay, so you have to keep in mind that case. So within our next chapter, we'll be investigating how to calculate the pressure. How can we calculate? Like, these are the two factors. We know that force and the surface area are the two factors that affects the pressure. But we don't know how to calculate the pressure. How we can get a magnitude of a pressure by using a certain unit. And how to calculate that pressure. We don't know how to calculate. We don't know a formula to calculate pressure. So my dear children, within our next chapter, we'll be discussing how to calculate this pressure and to develop a certain formula by using these two essential factors necessary for the pressure, right? So till we are going to meet with the third chapter, right? It's time to say goodbye. Stay with me on the third chapter, my dear children. In the third chapter, we'll be discussing several questions and we'll be discussing how to calculate this pressure by the usage of these two factors affecting the pressure. So until we meet again with the third chapter, it's time to say goodbye.